It's still, oh, there we go.
Uh,
Now we're live.
I think we're live now, and
We're live.
we got two new people that weren't on last week. So maybe quick intros.
So I'll go first. I'm James Bear. I've been working on the Cloud Foundry project last 3 years or so, and looking forward to some tech talk.
As we do.
Cool. And I'm Cornelia Davis. I'm Foundry product team and platform engineering, and love to geek out on Cloud Foundry. Been doing it for about 2 years.
Nice.
Fantastic. Welcome back, Andrew and Josh.
So now this one is like a staff meeting.
Well, we need Rodrigo Flores or somebody in here just to keep us on.
We need Beaker or Neil or someone to break it up.
All right, I'll keep tweeting at them while James gets his
I
part
think
up.
that was the fun part last week, is that I didn't know that I was giving a link that anyone could join, and then all of a sudden these people started showing up, so that was fun. So I actually have this affinity for this presentation that Cornelia has run through before, and I thought we could have a quick chat about it as a kickoff topic. I don't know if, Cornelia, you want to introduce the topic a little bit from your travels?
Sure. So the topic that James is talking about is, well, I guess the simplest way to put it is what the heck do we mean by it when we say IaaS plus plus? So let me start out with telling you that. Some of you may have heard us use that term before. But I spend a fair bit of time out with customers looking at the state of their clouds. And honestly, a lot of customers out there have built, a lot of enterprises out there have built infrastructure as a service offerings. They've also recognized that that's not enough. And so they want to move up the stack. As a service, so that when somebody goes to a self-service portal and requests a virtual machine or more than one virtual machine, they don't just get a VM and that with maybe an OS on it. They get a VM that has some additional middleware installed on it, and more than that, they even get a cluster of VMs. So they might go to a portal and say, "Hey, I need a development environment," and that's going to give them it's going to give them a 3-tier application. It's going to give them 3 VMs. One has a database already installed on it. One has Tomcat already installed on it, and one has the Apache web service, Apache web tier or HTTPD installed on it. And that's what I've seen with a lot of enterprises, is that's where they've moved up the value chain. Now that's markedly different from what we offer in Platform as a Service. But without even going to Platform as a Service, one of the things that I've learned over the course of the last year or so and looking at some of these systems is that there's a whole bunch of pain points that remain. It hasn't quite addressed some of the things that they need to be able to bring software to market faster and more frequently. That's even more important. So I'll pause there for a moment instead of getting on my train.
Well, I think what's fascinating to me, Cornelia, is like how you have these discussions with organizations about this, and how having a clear API for operators and a clear API for developers relieves a lot of tensions in the organization, and the idea that a middleware template deployment on infrastructure leaves both, basically two people want root access. The developers want root access to the middleware, and the rest of the team wants root access to the OS and the systems, and there's not a clear separation of duties there.
Yeah, totally. And I actually have a picture. Maybe I'll just go ahead and bring that picture up. Yep. There's a number of pain points. It's not just this one point, but maybe I'll bring up the picture and we'll go from there. So let me actually share. Screen share. There we go.
Pull it off.
Okay. There we go. So the picture that I'm referring to, actually let me show you a couple of other pictures to start. So you guys see it?
Yeah, we can see it.
Okay, cool. So this is a fairly common picture that probably everybody's seen already. Is this notion from traditional where you have management that you need to do for the entire stack, including physical servers, all the way on up. When you go to infrastructure as a service, you virtualize, not only virtualize away that stuff, but you actually have some self-service. That's what the as a service part is. People can go and they can request these things, and then it's automatically provisioned for them. And then there's this picture where we move over and we say, well, platform as a service actually gives you a layer on top. Now, one of the things that I've started doing is I've started pointing out, I made a slight change in this slide in that it doesn't say IaaS here anymore in this far right-hand box. It says virtualized infrastructure. Because I've talked to a lot of enterprises that when I start to talk to them about Cloud Foundry and PaaS, they're like, oh, well, we're not quite ready for that because we need to put our IaaS system in place first. And so one point of clarification is to say, no, actually you don't. In order to install Cloud Foundry, you need virtualized infrastructure, but you don't need to have the as-a-service part. You could just point to your vSphere environment. Now, in some cases, it is infrastructure as a service. So if you go on top of AWS, yeah, that's an IaaS system, and then you layer on top of that. But you don't have to have that. So.
But spending a lot of time on just how to get developers access to VMs on demand that they then have root privileges on.
That's right.
Is not the high-value leverage point for software delivery for these people you run into.
That's exactly right. So if you go over to this next picture then, let me show you, here's a picture that shows what IaaS is versus IaaS++. So if we move over here, this is what you have. You have this bundle, this thing that's in order of precedence here is around the parentheses. So what you're getting is infrastructure plus middleware as a service. And it's really important to notice the difference between there's not a clear boundary here between this middleware layer and the infrastructure layer going down below. And that's valuable because we all know that Bosch actually provides that abstraction layer that allows us to have infrastructure abstracted away from the PaaS layer. So that's important too. But that's not actually the punchline that James is digging at here. It's not the punchline that we're driving at.
This is the slide I love.
Yep, this is the punchline.
Yeah.
So what you get when you have infrastructure plus middleware as a service, and I've seen this at numerous enterprises that have gotten so far as to have an infrastructure plus middleware as a service. It's a lot easier to say IaaS++. To have that type of an offering is that in some of these enterprises, I got a chance to talk to ops teams who are sometimes responsible for this platform that they're building, this I plus M as a service. I also got to talk to app teams that were leveraging that and got to really find out about what was successful and what wasn't. And there's some things that the app teams were really happy about. They love the fact that they get this provisioning because they were still honestly working in the very old world where they had to request things to be provisioned. So there's definitely value to the developer, even in this type of a thing.
I see that a lot. I hear it described as they were so starving, it took 10 months to do anything before, that this is great, but then I think people don't understand that there's actually a better thing you could do. So I love to hear the punchline here. It's all
And so in this picture,
Can I up level a little bit here on this because I get the technology argument, and I've built IaaS++ systems, and I see why they fall down in a certain sense. But I think the heart of the counter argument, if there is one, or the argument that's being made by the folks who are building these, is to say, look, Gartner says bimodal IT is the future, which is we keep ops people doing the opsy things, and we keep dev people doing the devy things, and they don't step on each other's toes too much, and so you still have this clean demarc line. And that's kind of what you're saying you get when you've got PaaS on top of IaaS, which I'll come back to in a second. Then we've got the whole story around innovation culture that says, forcing these two teams to work together and do this DevOps thing, which I want Schaefer to weigh in on in a sec. It's not just that you go fast because you're tearing down these silos and all the broken communication between these different teams. It's also that you've improved everyone's ability to collaborate because you're forcing them to talk to each other. So I'm not sure that the argument of having a super clean demarc line here is actually as suggest because they don't have to change how they're doing business.
Yeah, so let me tell you a story here. So I was talking with an enterprise. It was in we were talking about this picture. We didn't have this picture in front. Actually, we were talking about this picture. And what I learned, and the reason that in fact, earlier, one of the interviews I was in, that brought this picture kind of into my brain, was that I talked to the IT ops team and I talked to app dev teams in this particular enterprise. And they had this great thing where they wanted their app dev teams to do more of the operations of their applications. So they were doing a little bit of the DevOps thing at that layer. But then they still had this IT ops team that was responsible for this box, this gray box that you see on the screen here. And what happened was that these teams weren't always talking to each other. When they had an issue in production, the app team would get paged because their app was down. There was some issue with their app. The IT ops team might also get paged. And both of these teams would go in and they'd start poking around. And they literally sometimes, now in theory, the IT ops team didn't give root access to the VMs that were running the web server, the Tomcat server, or whatever the case may be. So in theory, they didn't have access. But if you knew somebody, then maybe you sweet-talked your way into getting SSH access into the box.
What I love about this story is that it came down to like Shawshank Redemption style, I know a man who knows how to get things, sort of back channel.
Yep. Happens all the time. And so what they did was they ended up in this situation where these two teams were trying to remediate an issue, and they were literally stepping on each other's toes. The app team was changing a configuration setting somewhere on one of the boxes, and the IT ops team was like, well, that didn't work, and they would change a setting back. And they were literally stepping on each other's toes.
But you see that happen even inside of dev teams or ops teams when you don't have good incident management. That's not. I don't think that's purely division of responsibilities problem. It's more about coordinating those incidents.
I mean, we also talk about this idea of hacking Conway's law, right? And reverse Conway's law. Was that your Schaefer? Was that your term, or was that Anil's term? Because I was
going around. Actually, I think the first person who tried to publicize that idea was Adrian. It's the Netflix story, right?
Okay, I always called it just hacking Conway's, but the reality is, if you're not going to make them one team, then you need to take advantage of their separateness by keeping the technologies they're responsible for aligned to the organizational structure that deals with that portion. If you're going to actually collapse to a DevOps team where they both build and run, then it makes sense that they're going to have to figure out how to communicate internally. But if you're looking at a legacy enterprise and saying, we want technology to solve our problems and help us go fast, we don't want to embrace cultural change because that terrifies us. We get back to that thing Anil was tweeting about earlier with like, hey, the reason change is hard is because in order to embrace these new ideas, we have to accept that we might have been wrong about our old ideas, and nobody wants to do that.
So are we all the way to the end of the punchline?
We are. No, we're not to the end of the punchline. So let me just
jump there and then go back to this.
Yeah, there's more anecdotal stuff that I can tell you. It's not only about them going in and stepping on each other's toes. It's really about what's going on here, which is access. So the app teams, they didn't have access, for example, to the logs down here. So even if we had restricted them from SSHing into the boxes, they needed to go to the IT ops team to get the logs, to be able to try to figure out what was going on with their app. So this here is the punchline. What if they didn't have to go down onto these boxes to get the logs? What if there was a layer here that emitted all the stuff that they needed to be able to, at the very least, figure out what was going wrong with their app, change their app if there was an issue with the app, and redeploy it, by the way, or if they're finding that there's nothing wrong with their app, then at least it creates that clean separation. And this is really the punchline, is that we're trying to use, if we emit the right stuff at the right layers, then it allows us to separate the responsibilities of those teams.
I like the idea of this separation and the emitting these metrics and these logs. But I guess on some level, I don't actually feel like this is totally about the difference in technology, right? If you have orchestrated all these things, you can still have log aggregation. You can still have metrics. You know, there's a lot of these types of. I mean, I've seen a lot of different infrastructures. I've seen a lot of different teams, and I guess I'm still struggling with what these little boxes in this architecture are different. So to me, what you're showing in terms of emitting and the style tone is really not just infrastructure as a service plus middleware versus platform as a service. It's like a poorly implemented thing that's half done.
Well, that's the point, is that this is what I'm finding in enterprises, is that they don't have things that are getting emitted at this level.
Absolutely, because they're enterprise IT, and it's all been terrible for years. Yeah, of course. That's why people make money selling enterprise IT. Roll your eyes, Waters.
I guess I'm rolling my eyes because that's a broad statement. I think what's interesting about Cornelia's track to me here, though, is that there's two things. One is that is there going to be a motion to get things out of the box, number one, and that's your comment about poorly implemented. So hey, if they're not doing a great job of implementing it themselves anyway, that you might want something out of the box. The other is my interest in this idea that you've got a container-based process manager that rides on top of OS infrastructure, and that your interface to the container-based process manager is different, has a different, adapter than the people who are managing all the infrastructure underneath that. And that's somewhat interesting to me, because even in the Docker model, you say, hey, I'm a developer, I just want to push my Docker image to this cloud. You're sort of doing that same separation, and I wonder if there's not a macro trend here that's bigger than anything that we're just doing.
Can I just bring up how much I hate the idea of having platform be something that runs Docker images? And let me clarify this so I'm very, very clear. I love the idea of platform being something that runs Docker files. I hate the idea of platform being something that runs Docker images, because a BYO image is such a bad idea. It's actually a worse idea than a BYO VM.
So, hey, Bear, you
Yeah.
want to jump into a little bit of the practical experience there versus the
Right.
experience?
So it was funny. I listened to your Hangout last week, and or actually it was a call we were on together, Josh, this last week, where
Yeah.
you had brought this point up, and it was very much, yeah, James, remember we were in the room together and kind of looked at each other like, oh, that's a little off what we would have said. This actually comes informed to me from experience other people, namely IBM has had. They've been working on our Diego project on Cloud Foundry to help us bring, one of the aspects it's going to do is bring Docker images to Cloud Foundry as something you can have as a unit of currency. And the reason, if you look at the pure developer point of view, bringing a Docker file sounds great, because what that means is I don't even have to have Docker on my laptop. I can just kind of like take a couple of fields from text files that I find on the internet and take a couple people's Docker recipes and then ship it to the server, and all the build just happens there and starts running my Docker image on the server. So that sounds great, but what IBM told us, and these are people that I actually really trusted after hearing, we spent about half a day in a room talking about Docker, and it was clear to me that their learnings from Docker were very real. They were trying to take a lot of their complex middleware software and Dockerize it and run it, and what they found was that because Docker is comprised of these layers, and there's a couple of key parts of these layers that when you build a Docker file up, that is reconstituted and rebuilt when you say Docker build at that point in time. And you're not, the layers that you depend on are not like what in a Git world, which would be like a specific commit. It's more like a branch, right? So if that, you're really building on top of this branch that could be moving from underneath of you. And what they found was that because these branches are moving all the time, they could not get a repeatable build of something would be working. And then the Docker file would run again someplace else, and either, a lot of these Docker files are just doing apt-gets or downloading stuff from the internet. One of the dependencies would be broken and just not come down, or there might be a race condition and the layers wouldn't come down the same way, or that the layers had changed. So like all of these factors led for them to say, hey, we should have centralized teams building each one of these layers, and therefore just put them at, and going back to Cornelia's slides, just putting that final layer on the top, and then having other teams say, okay, turn the crank on this layer. It's time to repatch it because shell shock or some other thing came out that we need to turn the crank. But then only just put that last layer on top. So because of that, those learnings that they've had at scale, we said, you know what? If we have someone give us a Docker image that's been exactly the image they want to run, and let's say that's coming either from Docker Hub or whether that's coming from their private Docker registry, that's a repeatable thing that we can run on the platform. So that's what we decided to start with. And that's a really long-winded way of saying that we believe that at least the people in the room, there's about 10 of us at the time, as we talked this through over a course of a couple hours, that repeatability and knowing exactly what you were running in the platform side was repeatable was the characteristic that we wanted to start with, not the just ease of use from cobbling together stuff from multiple Docker files.
So I brought this point up with water, not guaranteed to have the same images if you do a Docker build. Like you have to ensure that everything in the upstream, but it's really the same dependency problem that you've always had for ages with packages or whatever, right? It's not a new
problem, and the excuse that they're using is the same excuse that gets used for puppy VMs. And the reality is, if you were using a Docker build environment where your Docker file dependencies will be pulled in from a local app repo, I mean, because what you're basically saying is there's all of these, because we're pulling random crap in from the internet, there's this miracle moment in time where that happens to work, and we want to preserve that miracle moment in time.
Mature organizations are managing their repos.
Yes, 80% of the reason that stuff in the outside world changes is because of security fixes. And when you're saying we don't want to suck any of those security fixes in because we don't want our environment to change at all,
then you might as well just, you got your hands.
I don't think that's what they're saying. They're not saying we don't want to suck them in. We just want to have one team responsible for it. Like,
yes, which I totally agree.
But actually, let's go back to the point.
Docker image.
We can talk about Docker, but so now you have a Docker thing. How are you going to get all the logs from these things that you got floating around on however many servers? Right?
This is my thing, Andrew. Is like I know you believe in platform, right? Like we all believe like you gotta have you don't want to just ad hoc every app that you run, right? You gotta have a systematic way of running your apps.
Yeah.
Do you like this idea of separation as part of platform, or do you think even in that platform world, dev and ops have the same sort of access privileges, same kind of interfaces, and it should continue to be unified like that? I think that's an open question. I don't know the answer.
So I think that there's optimal kind of phases depending on where you're at and where you're going. I think that I think it's insane to think that everyone becomes the same thing. Like I think that's a broken model. But I do think that it's one thing to limit access. It's another thing to understand what everyone's responsibilities are, right? And so it's one thing to say you can't see this thing, and it's another thing to be the one that's responsible for that thing, right? And so if you have everyone taking ownership for if you look at what's going on at Netflix and all these other things, everyone gets excited about the technology stuff, but it's a bunch of it's cultural, right? And you have cultures of high personal responsibility and high personal ownership for the outcomes. And if you have a bunch of people on whatever side of it, and they're not worried about who's going to get blamed, and they're not worried about what's going on, but they're trying to do the right thing, then a lot of this stuff just kind of fixes itself. So I think what happens in the enterprise is where you have calcified inertia around both technology and culture is they're sort of they're hamstrung at the outset for both those reasons, and then they're trying to compete with the quote unquote unicorns, but they don't want to be a unicorn, which is why we should get a Neil on this hangout right now, talk about that, and so then you end up with kind of these compromises in both the technology and the process, and it's suboptimal.
Cornelia, you've been in the trenches out there. You've been the therapist to all these organizations day to day. Should they? What's your perspective?
Well, I mean, there's no question that there are more than just technology challenges in these places, and that by providing a platform that has the right abstractions, that isn't the panacea. You aren't going to necessarily going to all of a sudden solve all those problems. there's a whole host of issues, and yeah, there's cultural issues and inertia issues and attitudes and things like that. But what I found by and large is that and yes, you could do things better in an infrastructure as a service-based solution, but I haven't found a company who is yet. They haven't come up with that new way, and that new way of making that demarcation between the dev and the ops.
And there's more to it than two other things. One is they also tend to struggle with developer experience. So like how you actually systematically turn the crank from app deployment to app configuration, and you spent one time where it was like 6-week learning curve of how to use the system.
Yeah, so I'm not saying that your experience is in any way incorrect, but I would suggest that we have a bit of sampling bias based on who you work for and the types of organizations that you're getting exposed to from being part of Pivotal and the platform. I think that there's definitely struggles on the other side of this. The Netflixes and the Amazons and the Googles. They're all doing things slightly different from each other. They definitely have different challenges, but they've all got somewhat different processes and challenges, and it's not trying to get logs from apps, right? They solved those problems 10 years ago.
So, and I don't want you to think that I was arguing against the idea that platform delivers more value than IaaS++.
It would be really boring if we hang out every week and agree with our architecture for an hour. So please.
Let me finish. No, I'm not arguing. I'm just arguing that I think the reasons why platform is so much more valuable, and this is the same argument I keep saying about Docker images. When an organization actually adopts platform and they actually start dealing with, the application developers own the responsibility for their code and for the services, the interfaces of the services they want to connect to, and that's it. When they embrace that, that's where they get all this value. And the moment that I see app developers thinking about specific Docker images, is I see we're drifting them back down the stack in the same way that you're saying we're avoiding doing by not doing IaaS++. That's the dichotomy I'm trying to call out here. Is we're saying, hey, platform gives a clean abstraction where app developers deal only with code, and that databases and middleware and services and infrastructure itself is all below that and hidden from view. But now we're saying, oh, but we're going to give them a backdoor into that now by supporting image format. Like, please don't do that. This is a road down where we are going to, and I know they're asking for it, and we're doing it because they're asking for it. We're giving them a gun to shoot themselves in the foot.
I couldn't agree with you more. But putting the Docker thing aside, the key word that you used just now is interfaces.
Yeah.
It's all about the interfaces. And in those enterprises where I saw what I just showed on the pictures, they didn't provide that clean abstraction. They did not provide those interfaces. And it's not just log files. It's even the way that they're binding to those services. Or it's the way
I think the service binding is a much more critical aspect of what platform delivers that you cannot get. Because in IaaS, and I don't care how much heat or Solemn you try and smear on top of it, it doesn't know enough about the apps and services to describe a relationship between them.
That's right. That's right. And so what's happened is that the people who are responsible for the application tier, they're given the wrong sets of knobs and dials. It's exactly that. It's the lack of in abstraction. And I wax eloquently all the time about our very simple services protocol. And the fact that it allows you, whether you have an external service or a service that's part of the platform, the way it's bound to an application is exactly frickin' the same. It's no different. And the power of that is just phenomenal. And so it is. You pick the right word. It's all about the interfaces.
So I kind of want to back up, and we don't have to touch on this too long, but the stack is deep and wide. I kind of have a convulsion every time someone starts talking about full stack. And no one's going to be an expert on every single thing, from the bottom at the kernel to the the database stacks to the app stacks to the JavaScript or whatever. They're whatever, if they're mobile, it's even different. So it's one thing to be able to see all this stuff, but no one is going to be able to troubleshoot effectively through every layer of that abstraction without coordinating and like without some separation of understanding and responsibility.
I mean, James, Bear, I mean, this is a big product question we think about all the time, right? Which is, how do you kind of do a reverse manifest of the state of an app after it's been deployed, even with different, logical partitions between it? How do you actually say, well, even though different people have different interfaces, here's what it actually looks like in infrastructure right now at this moment in time?
Yeah, that's right. And we've actually, Greg from the CLI team, for at least with respect to Cloud Foundry, is talking about being able to produce a manifest at any time. Like so far, we've been using it a lot for, I have a manifest now, make this app, make that representative of this text file, infrastructure as code, kind of my app represented all of its configuration, go make it so. Greg's talking about reversing that with a CLI command, the really nice, friendly, hey, this app is running, it's connected to so many services, give me that represented in all-in-one. Basically, right now, the cloud controller, and if you're talking Cloud Foundry parlance, is representing that in a database model and connecting some things together. But what if we were able just to flatten that out into a pretty simple YAML file that you can now have and reconstitute that? And we hear this all the time from whether it's our colleagues at VMware that are really kind of pushing for this approach, or some of the people at IBM that are a more heavier weight manifest that describes everything down to your infrastructure level. Our approach is a little bit lighter weight than that, but being able to back out of that and say, okay, some people have made some changes or things have been tweaked since we initially pushed it out there. What's going on there right now, and capture that state.
But in some sense, that's a deviation from infrastructure being code. The fact that people do that or can do that, right?
Yeah, I think that's a good point. I think that if you have these APIs and some of the APIs mutate the state, then yes, it's at some point in time you get to the point where someone's changed something and it's not just only onboard is the only option you have, where it has to go through your entire pipeline. And so I think that's kind of where this need for this API is coming from, is that people have said, hey, we have made some changes since someone has adjusted the database, or here's another example, people start out with a small database, and they want to graduate their t-shirt size, go from small to medium to large, and things like that change over time, so now we want to capture that. So you're right, Andrew, that this stuff is, going back to your point, I don't think you're going to find, there's so much variation, we don't want to put handcuffs on people to say this is the only one way.
I'm not arguing that should be enforced by the platform. Like, that's a process to say, okay, like, here's how we make changes. Here's our change control process.
Right.
We're treating this whole thing like one big application. Here's our development process. Here's our testing process. Here's our deployment process, and that applies to infrastructure as much as it does to any of the apps.
This is what I think of when you guys start talking about patching, and I get very emotional about this because I've dealt with systems where I was the IaaS layer, I was the ops team for the White House when they had access to the VMs and had root on the VMs and would just randomly go in and break shit and then want us to magically make that scale out because it was cloud. And like, this is literally where the origin of the word patch comes from, is gluing a piece of paper over a punch card. Which
seriously brilliant.
I wish we didn't do that anymore. Like, this is every IT revolution creates new jobs, and that's totally appropriate. And I reference Wozniak all the time. I'm like, look, when Woz created the Apple, it meant you didn't have to be a hardware engineer anymore to be a software engineer. And it created software engineering as a distinct discipline. And the invention of the platform, hopefully, is going to take us back to where you can be a programmer without having to understand anything about the operating system, ever. I would love my kids to grow up not knowing how to use a bash prompt, if they don't want to. I mean,
most programmers don't know anything about operating systems. What are you talking about?
No, but they still know how to do it. They still know that there are concepts of saving files and loading files, and that there's this idea of a process running somewhere, and there's a one-to-one relationship between processes and memory maps. Like, there's a whole set of things you actually have to know. Like, they don't have to know malloc, But
I get a little worried actually because I think that in some cases when you build up those abstractions and then you lose understanding of the underlying layers, then you sometimes solve. I mean, this kind of goes back to this notion of, what I have access to, what I understand in my full stack. You solve the problem at the wrong layer of abstraction, and it's suboptimal, and that happens constantly in our industry.
Yeah, I don't think we're going to be able to get away from people understanding the bash prompts, or because think of my background is Java middleware, so back in the days when I was working with WebSphere and WebLogic, we frequently, when crap would go really wrong in those systems, we weren't sure where to look, and so we'd have to drop down into OS tools. At some point, we're taking thread dumps in the case of the JVM. But once we got out of the JVM, if we're in JNI code for when it was calling out to C code, the only really way to do that is to have some really good set of tools that can watch what's happening between two different processes, analyze the network, and all that stuff's going. I just don't see that going away anytime soon. In order to be a competent have a competent operations team.
Yeah, I would have to disagree. I hope that it does go away. I'm with Josh on this one, and I've been doing this long enough that there was a time where I stepped through assembly code that was generated from a compiler because there was a compiler bug that I needed to find. By the way, I found one compiler bug in my entire career.
I found two.
And
I
had to step through the assembly code, but that was 20 years ago. It was before my kid was born. So I haven't had to go look at assembly code in 20 years. And so I got to think that we're moving up the stack and that we will be able to get away from that.
I don't think it's about patching assembly code. I think it's about finding where the problem is. If you have a slow performing application at the root level, and you know that being able to zero in on where that problem is to call in someone that's more specialized, I think that those are the kinds of things that I don't know. Is it that my network pipe? Is it me writing? Is it my file I/O that's to
James,
the disk?
there are a set of places where we never look because the problem is never there. So let's make some simple examples.
That is such a dangerous statement. That is such a dangerous statement. And
no, I agree it's dangerous, but I think
abstraction bar fight is just broken out. Like
when was the last time
grabbing a beer bottle and a bar stool, like
if the power being delivered to your server was not 60 hertz? We're like, oh, I'm going to troubleshoot this app, and I'm pretty sure that the performance problem is that the power is being delivered at the wrong frequency. When was it you actually took a multimeter into the data center to troubleshoot app performance? We don't do it because it's never the cause, right? It might. I mean, statistically speaking, it's more likely sunspot activity affecting the surface of the hard drive, and that's what I mean by a utility. The power.
So what I'm going to say is I think that you're going to see the complexity move up the stack, and in the waves of technology, that more and more people are going to live in that world. But I think it's dangerous to say that no one understands how that stuff works. And if you ever listen to James Hamilton talk about optimizing the power supplies for the Amazon data centers, then I would wager that he has done some of the things that you just described.
No, but we're agreeing. We're agreeing. When you're talking about optimizing, you're not solving an application problem. You're solving a problem with the utility itself. You're solving the problem of the basis of delivery of power, which is it costing you too much or not?
Yeah, actually, Andrew, I think you just argued in our favor, which is that he's optimizing for the general case.
No. So I think we're in agreement that you're going to, just like right now, the preponderance of Ruby devs, Node devs, they don't know how computers work. They don't. Like they might apt-get install something, but they're not going through the network stack. They're not looking at all this stuff.
I have one quick question I'd like to get people's opinion on. You talk about Amazon. I think it was a bigger abstraction leap to take all of compute and network and disk and mask that behind Amazon's APIs than just running this platform layer, which is pretty thin in terms of its using containers on top of the OS. I think that's a thinner abstraction than actually going to the Amazon infrastructure model. I don't know what people think.
What do you mean by thinner? I mean, I think it's more, this other model is more disruptive because people have been dealing with machines for decades. So I don't think that abstraction is that different. It's the same set of primitives that they've been working with since before virtualization. But now we're actually asking them to think differently.
Yeah, just sometimes when Bear is on a customer call, he reminds people, like, hey, these are just, he's got to get to talk about it. Like, look, don't worry, it's not like we reinvented the wheel here. This is just standard JVM running in a Linux container behind a software load balancer. This is pretty typical stuff. It's just very well integrated.
Right. I use that all the time. I basically say we're not injecting magic code in your JVM that's running on Linux. It's just at the end of the day the same, what you just said, James. Just the same process that they've always had. It's just the API boundary, going back to how you started this conversation, is now we have APIs throughout that to get the logs, to get set up security policies, to set up users, all the kinds of things that if you just start with the infrastructure automation, someone's got to be responsible, if you even have those capabilities at all, of getting those things there. And those are the things that I think are missed, where this is really, we've put so much effort into putting those APIs at the right space. Use them or not use them, they're there if you want to use them.
So I think what people are reacting to is the choice of wording around abstraction, because I do think, especially to do it at scale and seeing what's going on with the open source efforts in this regard is pretty telling. But it's a hard problem to build an infrastructure as a service and run it at massive scale and operate that. And we kind of take it for granted in our platform world that stuff's there. Right? Like Bosch doesn't even get started until it has that infrastructure as a service API to talk to.
But you just agreed with the point I was making previously by saying we take it for granted, which is another way of saying that notionally, if that abstraction is valuable and we've got it right and we've built it well, then the developers involved in building and running these apps, and in fact running them, including operating them, don't have to be the same people or even have to use and consume the same interfaces that of the folks that are providing that.
Yeah, absolutely. I thought we already got to the point where we agreed that there's going to be a preponderance of developers who don't understand how computers work.
Awesome.
So Rob Hirschfeld just joined, it looks like. I think I know Rob Hirschfeld well enough to introduce him without him talking. Good to see you, Rob.
James, good to see you.
Each week we have a fun surprise.
You all were having an interesting conversation, so I decided to jump in.
Yeah, great to have you here. Rob, who worked on the mustering of infrastructure at self layer, bare metal to OS up.
Yeah.
Well, there's also, and let me make an intro here, because Rob is now the chair, was previously co-chair with myself, but I've abandoned him, of the DEF-CORE Committee for the OpenStack Foundation.
Right.
And this notion that you get an abstraction right enough that the people above it can trust the abstraction, that is what DEF-CORE is supposed to do for OpenStack.
That's entirely right.
That of interfaces is promised to exist and run the same way in every OpenStack environment. So he's really been left with all of the hard work equation. So yeah, I think it's great that you joined us. Thank you so much.
You guys, I love talking about abstractions. It's my favorite. You were reminding me of my favorite quote on this one, which is that abstractions are useful until they're not.
I have a business topic because I threw together a little agenda for this week, and the next thing that was on it, not to get too into Gartner and what they do, but they've got this top 10 strategic trends for next year that folks maybe have seen, and things like computing anywhere, Internet of Things. But one thing I want to highlight on there is they have number 8 and number 9 are software-defined infrastructure and applications. Sounds like an abstraction to me. And web-scale IT. And so I think part of the business context that's necessary here is that it's not business as usual for folks. They're having to do things at greater scale. They're having to do things that might take on millions of devices. They're having to move faster than they ever have before. And it's not so much a Platonian argument about is abstraction better. To me, it's almost like necessary. Like, is abstraction the only way to get from San Francisco to New York is via an airplane, right? Like, is that the only way we can get to the scale we need to get to over the next 10 years?
So
I'm gonna
pull out another quote.
Josh is in first. Josh is in first.
I'm gonna let Shaver have the last word. So I'm gonna make 2 comments. The first one is just an introductory, connecting to what you just said, with the other thing that happened this week, which was there were some Nobel Prizes awarded. one of the Nobel Prize winners were the folks who make blue LED lights. And I thought that was intriguing because it is, to the best of my knowledge, the first Nobel Prize that has ever been associated with venture capital funding.
Wow.
That company was actually funded, and in fact, the folks were encouraged to go and even try and do this by Khosla. So what I think is interesting is this notion that one of the things that was in this article, they said, look, every light in the world eventually will have an IP address. When we start talking about the Internet of Things, we could just think about lights as being the first collection of, and maybe they'll have sensors on them and they turn themselves on and off. Okay, well that's both a device and a sensor with an IP, and now we can think about how many there might be just in lighting. The second thing I want to say, and I have no other opinion on your top 10 topics, is that I'm just a little shocked that you're still referring to Gartner, because I thought we were having sort of a progressive and futuristic conversation. And you're quoting folks who have 2020 at predicting last year's technology.
You know what it is I learned this tricks of the trade from Gary Ornstein, who did a really awesome podcast called The Cloud Computing Show. And even though he'd have like really smart people on, he'd have a little bit of structure, like just like, hey, go chew on this bone. And so it's not like I'm actually championing that Gartner is the oracle of what's coming up next at all. It's
you just
more
wanted a top 10 list.
Pardon?
You just wanted a top 10 list.
I just wanted some structure around, like, okay, we all think we're the smartest people ever, and we'd love to tell the world that right now, but a little bit of structure that this is how we're going to go about talking about things. And my posit is that, when you see the guys from Fastly talk about engineering, they've got a how long till they return a bit to you kind of problem. And they hate abstractions. Like, they're down there saying Linux is so broken, like architecture is miserable, and it's a piece of crap abstraction. It's just not good for the job that they're trying to do. And so again, to me, it's like, what's the business problem we're trying to solve for enterprises? And if it is at high scale, maybe we do need to take on more abstraction, or if we need to move faster, maybe we need the right interfaces that are clean.
So this is what I was going to say a moment ago, and it leads into, or what you said initially, and then also is reinforced by the Fastly comment, and it's a Ben Black quote, which is that the wrong abstraction is worse than no abstraction, right? And so when you have a kernel that's optimized for some dude's laptop, then it might be a little thing that's fighting against you if you're trying to optimize for the speed of the first byte that you return it to people across the planet. Just saying.
I think exactly. I think you can go way, way deep depending on your use case. Of abstractions are 100% broken for certain use cases.
I guess that was the point I was trying to make with abstractions are useful until they're not. Is that we need to build a chain of abstractions, and then depending on your use case, you're going to end up breaking one of the links. The worst systems that I've seen, and this is why I think visual programming languages usually fall down, is that you have to be able to get out of the paradigm, the abstraction paradigm, for your use case. And so, Fastly's they probably use tons of abstractions. They probably use all sorts of things. The one place where it breaks down, they need to tear it out. And if the boundaries aren't good, then you have a really serious issue. It's one of the things Josh and I were hitting with OpenStack, is that people didn't identify these boundaries between all these projects. Then they cross over, and they have all these cross connections that are impossible to disentangle. And it's been one of the challenges with trying to make those individual projects stand alone, or even progress alone. And so I think it's really important to understand your abstractions, but I think as soon as you make them required, you inhibit scale.
Okay. I think you beat this horse in every part of its body. Next one, Bear. What's on your mind? You're the pragmatist. What I like about
actually, I want to beat that. I want to go back to the comment. I think we got sidetracked.
Get a glass of water. I'll be right back. You guys beat this one.
No, I think there's some interesting stuff to talk about because we kind of got sidetracked and fixated on this abstraction argument instead of talking about what's the next thing for enterprise IT. And for just a casual observer and going back to the light bulbs and the sensors, there's definitely a wave of transformation where what people once thought of as scale is gonna change, right? So if you used to think that 100 servers was scale, then there's a whole new thing coming for you. And what Google is doing now, that might be a ways off for other people, but what a lot of these e-commerce or big web companies were doing 5 years ago, that is going to end up being the norm for a lot of enterprises 5 to 10 years from now. Like, they're just going to have to be managing those kind of systems at that kind of scale with that kind of efficiency, or they're going to lose. They just can't play that game.
I think that's the key point that you just made. They're going to lose. Like, why is that the case? And it's just basically natural selection, right? Like,
it's a Darwinian process.
I've got two anecdotes. I love anecdotes. The first one is Domino's Pizza. I saw somebody tweeted yesterday or the day before that, posit that Domino's Pizza is a software company. And then I went to order pizza last night, and I realized that they had updated the Domino's Pizza app, which I live in Canada, in a small town, and I haven't ever called Domino's on the phone. I just use the app. And they've done another update, and now I get this little progress indicator that indicates, is the pizza made? Is it in the oven? Is it in the driver's car? Is the driver... And then they call me. It's an automated IVR system that calls me to say, the driver's on the way. You should go out onto the front porch. That's not just good for me. It's really good for the driver. It's really good for the local Domino's station. And by the way, I pay with my credit card on the app. But Domino's is a software company, which is this whole idea of, software eating the world. That is, they probably make software now better than they make pizza, but their pizza doesn't have to be that good if it's that easy. Which brings me to the second point, and James will remember this. We did a deployment at a very large telco where they were doing a Hadoop environment, and they wanted to have Cloud Foundry connected to Hadoop, and the question was, do we put Hadoop on bare metal servers, or do we put Hadoop into OpenStack? And they're like, we think it's going to be slower inside OpenStack. And that really matters. We believe that this is super important, that Hadoop has to be fast, and therefore we have to avoid those abstractions. It has to be on bare metal. So we did 2 months of benchmarking. And at the end of 2 months of benchmarking, we thought, yeah, it is slower. It's actually 11% slower than bare metal, high bench on everything that you're doing.
11% performance hit.
And 1,000 times faster.
6 minutes versus 6 hours for cluster setup. And that was optimistic 6 hours. That was like best case 6 hours.
Yeah.
Yeah, but that's a fixed cost you pay at the front, right?
Then that's why it depends completely on your map reduce use case, right? If you do a Netflix,
does it only pay up front if you're scaling? No, I mean you pay it all the time.
Or if you recover it. Yep.
Or you could actually get better at managing systems and put them on. Like you kind of get better at doing this. Like people can put bare metal. People can put bare metal in their clusters.
No, I'm sorry. The people who were taking 6 hours are the people who wrote Hadoop.
Andrew, you can't have it both ways. You claim all the developers.
They don't know anything about bare metal.
Whoa.
They're the best people at this.
No. The people that wrote Hadoop are not the best people to configure servers. Absolutely not.
Correct. Absolutely.
But Andrew, here's my point. You're pretty critical. You're pretty critical of these web developers not understanding the operating system layer or not being able to troubleshoot effectively, right? That was
No. I believe they can. I believe they shouldn't have to. That's the point.
Well, my point is that Andrew specifically several times earlier has said that the web developers writing Ruby or Node apps aren't effective at troubleshooting or doing the more sophisticated stuff at the layer underneath. But yet here he is. I find this point odd in that you're saying, well, these people have to be better, but then it's very similar to your point that they're not. If you're talking about the other abstraction layer.
No, so there's a couple of different points that we're all arguing, and I don't disagree with the point you're making. That is probably the standard for what many of these enterprise ITs guys are going to have. But the people who wrote Hadoop are not the same people that have optimized to do provisioning and configuration of servers. I'm just going to throw that out there.
I'm just trying to avoid picking on a particular company, but let me just point out that the folks who take 6 hours to set up a Hadoop cluster are the folks who are considered to be the best consultants in the world at setting up Hadoop clusters, exactly like this. And they do it by
Uh,
hand. They don't even use scripts.
but wait, hold on a second. And they're starting from ready state. Those guys don't show up at a site until you've got all the networking OS installed, all the DNS, all the IP ranges, all the NICs teamed, none of that stuff. And yeah, I mean they'll get back on the plane and go home if the system's not in a state where they can just run the scripts and do the install. Installing Hadoop is not hard once you've gotten all that other stuff done.
Agreed, but I'm just saying we rebuilt Hadoop every 32 hours for 2 months, and they never scripted it.
This is why I'm doing what I'm doing, because this is the state of the universe is that real deployments are applied, rinse, repeat until you get them right, and you have to have a system in place that can do that. The issue here isn't the abstractions. The issue is the sharpening the saw problem, where people don't actually take the time to understand how to do a deployment. We don't incorporate the ops deployment cycle as part of the development cycle. We don't expect developers to do that.
Behavior change.
Yeah, it's a non-learning piece.
Right, but this is the thing that I see that's changing, and this is actually what I see one of that's happening in cloud stuff. The benefit is not cloud necessarily, but the fact that we're forcing people to understand scale operations and automated operations. That you can't consume cloud effectively, especially something like OpenStack effectively, if you don't start automating your deployments, because you'll get crushed by the upgrade cycle. And so the only way we can deal with this, right, the enterprises can deal with this, is by jumping into the next generation of IT. The defense is not to lock everything down and pretend you're not going to change it. The defense is to make it so that you can change faster, right? If something's hard, do it more often. I think that's what we're seeing is the sea change, and people are being rewarded for that. They're not being rewarded for, I mean, I'll call Red Hat to the carpet for taking an operating system and pretending like you're going to have a 10-year life cycle on it. I think that what we're seeing is the companies are understanding they've got to be able to rebuild stuff from scratch much, much faster. The turn rates are going quicker as a defensive strategy.
This is just the sort of basic lean manufacturing cycle time advantages, right? Like, this is Toyota wrote books on this for decades and decades ago, and the fact that we're just like we're applying it to software now, but yet again, I'm struggling.
But I mean, this is, and the funny thing is that we're tying this up with abstractions, and I actually think they're reasonable things to commingle.
Well,
right.
So here's the question. You mentioned Gartner, James. So let's go back to the Gartner thing. When we were a Gartner client for a period of time, the discussions we always had with them was saying, hey, look, you guys are all super smart and you're startup people and you're vendors and you have this vision of the future state of what IT could look like for this company or all companies in its class. And they're over here somewhere, which is, what IT looks like for them today. What's the jump that you think they can make? Because if you go and you sell them right in front of them, like this is the tiniest jump, they don't see enough value to do it. They're like, no, we need a bigger jump than that. If you try and take them all the way to the end state, they can't make it. And even the ones that get excited fail. And then you've actually just made it worse for them by challenging them to do more than they can actually embrace. So what's the piece? And this is why I keep asking about the Docker images or the abstraction, and are they allowed into IaaS? Are they allowed to SSH into Bosch deployed VMs? And does that mean the VMs are tainted? Or does it mean we have to reverse engineer the state of the system again? Like, how far into this new worldview are we trying to push folks or asking them to jump?
I think it's very use case specific. So I think in the use case where you want to deploy SAP every 18 months with lots of lockdown around process of how you write your systems of record, I don't think that the old way was completely crazy. But I think that when you're driving business value from rapidly evolving scale-out API interfaces and things that made the big web companies rich, like, to me, it's more of like, are the clients that Gartner advises discovering new business models where they need that, i.e. your Domino's example, right? Like, how much is the Domino's thing happening to banking, to manufacturing, to oil and gas? I mean, before we get too cute and proud of software, I went and talked to one of the largest oil companies in the world, and you stand in front of them there, and yeah, I think they can get a lot of value out of certain data analytics and everything else, but just driving a web app, like, what's that going to do to an oil and gas company? So I think it's as much around what's really changing in business models and having to get to scale at IT, and that's the interesting part of the conversation for me.
I think watching each of these industries evolve at whatever pace they need to is a function of what kind of entrenched advantages they already have with regards to resources, regulation. There's a bunch of other factors, especially when we start talking about physical goods. But just in the context of oil, I think that there's all sorts of IT projects already just going into exploration, modeling, all the types of. I did seismic inversion simulations before in grad school, looking for anomalies in the ground, trying to find deposits or whatever. And I'm sure that all that stuff could be accelerated, and the first people or the ones that are able to leverage both the entrenched advantages they have in those markets in conjunction with higher throughput and advantages with their IT, they're gonna win those markets, and they're going to be the ones that lead in the next decade.
I think so, and just to quote Gartner here, they say, Gartner notes that in order to deal with rapidly changing demands of digital businesses, shifts both up and down require computing to move away from a static to dynamic models. Like, they're basically saying that every business has to move from a static to a dynamic model, and that's where I come back to Cornelia's point around interfaces. If you're all running around, it has to be choreographed in a much tighter way than the old workflow-based approach, I think.
What if here's a crazy radical idea.
Let's do it.
If we believe that adopting Cloud Foundry is a game changer for most companies to do it, seriously, I put my nuts on the line here by joining this company. We think that a giant organization in the world is going to make or break their business over the next 10 years by using CF instead of doing it however they're doing it now or going with some other product. Take payment in equity and become a hedge fund. This is my new idea. I think everything should be a hedge fund now. But wouldn't that be awesome? This is the index funds that have successfully deployed CF. This is what I wanted to do with OpenStack, by the way. I was like, companies that are getting all in on OpenStack, that is the best leading indicator of their willingness to be a different kind of business over the next 10 years.
Well, just while you're on that all in on a real high-performance abstraction, did you notice that Oracle, who I've been poking in various body parts, org recently, hired the ex-head of a guy that worked on App Engine at Google, and then who ran Snapchat on App Engine, is now running cloud at Oracle. So it's almost like they're kind of long on this platform as a service abstraction game too. If you read those team leads.
Yeah.
One of the things you just said struck me, James, and I got a shout out to our boy Matt Stein. But you used the word choreography.
Yeah.
And I think that that's true. And the example he's giving is the difference between orchestration and choreography, where in choreography there's sort of like this framework for the dance, but each of the dancers is responsible for their part, and I think that's probably the proper use, and it's kind of reinforcing the point I was trying to make earlier about you have to impact. Like, if you don't believe your developers are smart, and you don't believe they're going to make good decisions, you're going to have a hard time making good software. Bottom line. Like, if you don't have smart developers, you're playing the wrong game.
Yeah, and I think it's that choreography is where it actually gets back to Cornelius' point, which is that no one's questioning who's throwing the pass and who's catching it, and no one's questioning kind of the role that they play. And when there's something to be done, they have their very complete interfaces. Now that doesn't, to your point, obviate the fact that at some point when something goes really wrong, you're going to have a full team huddle, maybe full stack debugging, and tear down the engine.
broken play, diving catch in the end zone.
But you shouldn't have to be tearing apart the entire engine every time you just want to update code. And I think that gets to the choreography and ultimately why, you know, abstraction plus teamwork really helps you move faster. So,
All in favor, say aye.
Aye.
by the way, Andrew, you're giving us a hard time with making Nick Weaver really just lose it on Twitter. Like he's just like he can't stop shouting you out right now. So I think he's pounding on the table for you. Somewhere.
I try to keep it real.
Yeah, it's good.
It's correlated with the beard length, I think.
So
Yeah, that thing's getting long, dude.
we've been talking a little bit. I want to close out with one last thing. Is you know, so we just shipped a new version, and James Barrow was intricately involved in that, and we provided a new level of control to help this choreography, if you will, and that was these app security groups. So James, do you want to? I'd love to hear a little bit of app security groups, and then also the metrics pipeline that you're working on, because I think these are things that'll help in the dance a little bit.
Yeah. So one of the things we kept hearing about from customers was that they like the idea of pre-provisioning a bunch. They like the experience of using the platform, getting stuff right away, and being able to put their applications on there quickly and get apps and services deployed fast, all that kind of stuff. But the things that they wanted to do that were more when they actually tried to take that to production, they're like, oh boy, I don't want just any application on this platform to have access to my production database. I want to treat different applications differently with network app policies, and I don't want to necessarily set up two separate platforms, one for the dev applications, one for the prod applications, if I can view them all the same. And so we listened to the requirements that were coming in, and we said, well, geez, actually we could still use the same infrastructure underneath if we treated the applications differently from a network access policy. So we found a way is to codify, as from an operator perspective, which applications can have access to which parts of the network. And we use the implementation kind of uses the same kind of primitives that normal firewalls use. We use IP tables, and we have a way for network administrators to come up with a set of policies that some applications should be using and differentiate that from another set of applications. And we use the same terminology that they're used to in IaaS, like security groups in either OpenStack or Amazon Web Services, and we use that same concept in the platform tier. So that's really what it is. As an administrator, I can set up different pockets of my one installation of the platform, and some applications can access a network endpoint, let's say a production database, and the developer applications can't access it. That's the essence of it.
This, I think, is just really amazingly powerful choreography, whereas before you'd have to go down to, I mean, Andrew, you lived this when you were dealing with that motion picture company that was doing VLANs for their PHP apps, right? Like you'd have to go configure the layer 2 network to isolate your PHP app, which was about a movie. You know what I mean? Like that's using app security groups in the platform and keeping the app completely scalable, right? You don't have to like, change or scale the VLAN. You can change and scale the app as you want. I think that's a completely more effective choreography between networking and the app team.
Yeah, I think it's a super powerful concept. James, where do you see this going in terms of application-centric security in general? So this is obviously, you know, this attacks that at the network layer.
Well, I don't know where James thinks it's going to go, but having had recent discussions with some of these large financial kind of payment processor type companies, they already have this sort of application layer 7 firewall set up in their development environments, and they essentially are going to have a hard time using something like Cloud Foundry. I mean, I think maybe we can meet them in the middle until you have this way to do basically role-based access control per app,
Right.
app-to-app role-based access control. So
Well, that gets up to we've taken care of the layer 3 networking issue, right? We said, hey, we'll
Sure.
put your IP tables. And James is also working on right now doing app auth. So there's a whole roadmap that I think is very powerful around the layer 7 controls, again, built right into the app, choreographed right from the app-centric model of the world.
You know, what we've done so far with Cloud Foundry, to speak specifically about it, is we said the applications themselves are responsible for doing their authentication and authorizations themselves. It's an application-aware concern. It's not something you can get from this platform API yet. So this first foray into app security groups was egress, right? From the application, what can I access? And we put a platform API around that. But the inbound network has not been something that there's platform APIs for. So that is the next step, Andrew, is to be able to say on the inbound side, what can even access my application? Who can do it? Maybe what protocols and transports can they use? How am I going to negotiate those with people, whether that's something like SAML or OAuth? Those are the kinds of things that we're going to be working on next. And we already have the ability we have an OAuth 2 server built into the platform, and it can speak SAML. So we have some ability to glue some of these things together now, but we want to be a little bit more rich about how we can do that.
Well, talking to these other people, they had everything you associate bad with firewalls and processes was probably doubly so with this case, where they had to have access in, out, and basically every field of the API call had to be conforming to these things, and then their apps actually went through this additional middleware that enforced those.
Was it like an appliance of some kind that really understood their REST API? That's basically what you're saying?
Like, it's basically this big mapper in the middle that everything goes in and out of, and it has to say, like, you just did a validation on...
Is access allowed, is not, and kind of
Exactly.
Yes or no?
Like, literally, like, if it's a layer 7 firewall.
Yeah, makes sense. Let me address the other question. So we are going to work on stuff like that to see what makes sense to put in the platform there. I think we're hearing people have pain around doing this, making the application be aware of itself, or in Andrew, like the case you just brought up, they're just not even allowed to do that. So that all works at the platform today. You could put one of those appliances outside that middleware in front of the paths if you wanted to, and only have the applications must go route through that outbound layer. But we're hearing some pain, or as we're talking to these customers, so we'll probably add something there. Let me shift direction, say the other thing that James asked me to talk about where we're working on. And I think this is going to be a pretty fundamental thing that is very differentiated for the platform when we get it in, is just having the applications expose their metrics about themselves that the platform's already aware of. Because we have this load balancer, the router right in the middle, and everything's going through it. I don't know if you've ever seen Elastic Beanstalk. When you spin up an image, you get these really nice, pretty charts and graphs from Beanstalk right out of the box. And that's the kind of thing that we're going to be able to do in the platform for every single application, because we know, basically, think about the HTTP access log you get in a normal web server. You know, when you aggregate all that stuff together, you know what the throughput is. You know what the latency of requests are. You know, you can even pinpoint a particular endpoint of an application and get that detail about that. You get the response code. So you get a lot of rich information about these applications that, in the enterprise, what I've seen is that the only time they get that kind of stuff is when they really weave something like a CA Wiley or an APM tool like a New Relic or an App Dynamics into their platform, and it usually only they do it when they have a problem, and it takes them a while.
Once the app goes yellow or maybe red, right? They're like,
yeah,
not working. Now we need to know things.
And when someone asks a question, well, what was this doing a month ago? Well, you're like, I don't know. We just installed it a week ago. So those are the kinds of things. Being able to emit those metrics is just something that comes out of the box of the platform is something we're looking to do next. We have the fire hose working right now, where as an administrator you can get all the logs and all the metrics that are very raw for all the applications in the platform. That's like the Twitter fire hose, right? It's too much data to make sense of. We've got to aggregate it and filter it down. So that's kind of where we're at right now, is at this fire hose level. But we'll have engineers hard at work at getting to that kind of clean, cleansed view of that information, where you can look at the prism of just your application and what it means to look at those metrics. And then think even further out, going to have a foo metric for your application that's a business metric that you're in control of, and being able to emit that in some stats, like StatsD or whatever you're comfortable emitting that in SNMP or something like that, and being able to have adapters to plug into that metric system. That's kind of where we're going. So like when going all the way back to the beginning of this conversation, you talk about, oh, what's the difference between these IaaS orchestration platforms that people have incrementally built out over virtualization, and something that comes in a platform. And that's going to be something that I think is going to raise the waterline of what people are going to want.
Yeah, and so, I mean, I think we should wrap pretty soon here. We might take
We'll just end with a here.
Wait. I got two public service announcements. The first public service announcement is, of course, that Pivotal is always hiring, and there are enormous
What are you up to?
job openings.
Watch out, we're ravenous.
We are like, if you were watching this and you understood any of the words that we used this evening, you could probably apply for a job at Pivotal. And the second is, if you're curious about these cool things we've been talking about in terms of Cloud Foundry, Pivotal CF, the commercially supported version of Cloud Foundry, offered up by these fine folks at Pivotal, and you can download it and try it out for free at, I don't know, some website somewhere. If you can't Google it, you probably won't be able to get it installed.
Pivotal.io, and then there's a link. It's an obvious link from there.
Yeah, all the things we're saying have real product behind them. This is not an academic class, and I think that's the fun thing, is that we're betting big on this, and we've got hundreds of people in R&D. We're not just like having a hand-waving beer discussion about abstractions. Like
there's a lot less bourbon this week.
What's up?
There's a lot less bourbon this week.
You know, what I found last week was that I always work Sunday nights till about 1 a.m. and after having a few bourbons, my Sunday night productivity went down, and I ended up starting Monday morning in an email hole that I did not have a good time digging out of. So. There was
Especially if they were you sent them with under the influence of bourbon.
Well,
that's a retractions there.
Yeah, you know, I try to keep the conversations fun and lively, but I got to work after this. So. Thanks everybody for hopping on. Amazingly, I think this went even better than last week, so we'll just keep doing them. Nick Weaver better hop on this next week, and there's a couple other folks I think that are stalking us but not joining, so I can't wait to have them on, and they can tell us what we're up to. See you guys.
All right. See ya.
Good night.
This was cool. Thank you.
Cheers.
Good night.